Hello and welcome. Do you want to successfully complete the D684 OA exam? Then you are in the right place. Our website has free questions and answers for the D684 OA exam. We know OA exams are tough, so our guides and practice questions are all free. With over 100 plus success stories, we have proven our videos will help you pass your exam on the first attempt. In this video, we will cover questions from object-oriented programming, programming paradigms, data structures, algorithms, software engineering. So let's get started.
Question 1. A developer at a gaming company is building a system where each character in a game shares common traits like health points and attack power values. Which concept best allows the developer to define these shared traits once and then reuse them across characters? Your options are A. Polymorphism, B. Encapsulation, C. Class, D. Instantiation. Which one is it? Pause the video if you need more time. The correct answer is C. Class. C is correct because a class serves as a blueprint that defines shared properties and behaviors. Every object created from that class will automatically possess those traits, making code reuse efficient and reducing development errors significantly. A is wrong because polymorphism allows objects of different classes to be treated as instances of the same parent class. It handles method behavior differently across objects, but does not define the shared blueprint structure itself. B is wrong because encapsulation focuses on bundling data and methods together while hiding internal details from outside access. It protects object integrity, but does not create a reusable template for shared traits across characters. D is wrong because instantiation describes the act of creating a specific, usable object from an existing class. It produces individual characters from the blueprint, but does not define the shared traits and behaviors initially. A class is the foundational blueprint of object-oriented programming. It describes what a category of objects will know and what they will be able to do. Written once, reused everywhere. Every class declares fields, which store state like health or attack power, and methods, which define behavior like taking damage or firing a weapon. The class names these members, but each individual object created from the class carries its own live values. Think of the class as a cookie cutter and the objects as the cookies stamped from it. One character class can produce a knight, an archer, and a mage, each a separate object, each sharing the same structure defined in that single blueprint. It is easy to confuse a class with related concepts. An instance is the live object built from the class, one step downstream. Encapsulation is about hiding fields behind methods. Inheritance passes a class's structure to a more specific class. Only the class itself is the upstream blueprint where shared traits are declared. Whenever a scenario describes a single template that many similar objects follow, or uses words like shared, common, or define once, that is pointing at the class, it is the one place where common structure lives, making everything else in object orientation possible. Question 2. A software team is extending their employee management system to add manager and intern roles, both of which should share core attributes from the existing employee class. Which object-oriented feature best supports building these new classes without rewriting all the shared code? Your options are A. Inheritance, B. Composition, C. Instantiation, D. Abstraction. Take a second. Which answer would you pick? The correct answer is A. Inheritance. A is correct because inheritance lets a new class derive behaviors and attributes from an existing parent class. This approach supports code reuse and reduces duplication, which is exactly what the team needs here. B is wrong because composition involves building a class by combining simpler objects as members. While useful, It does not automatically pass down existing attributes from a parent class in the way this scenario requires. C is wrong because instantiation refers to creating actual objects from a class definition. It is a runtime action, not a design time mechanism for deriving new classes from an existing one with shared attributes. D is wrong because abstraction hides internal complexity by exposing only the necessary details through a simplified interface. It focuses on what an object does, not on reusing code from a parent class across new classes. Inheritance is a design time relationship between classes that lets a new class automatically receive the fields and methods of an existing one. No copying required. It models the idea that one class is a specialized version of another. The existing class is called the parent base class or superclass. The new class is the child derived class or subclass. The child starts with everything the parent defined and only needs to declare what makes it different. A payroll system is a classic example. An employee parent class holds the shared core, name, identifier, and salary. A manager subclass extends employee, inheriting those fields automatically, then adds a team roster and its own bonus calculation. An intern subclass does the same, gaining a supervisor reference and an end date instead. Inheritance is easy to confuse with composition and instantiation. Inheritance is a link. A manager is an employee. Composition has a link. A car has an engine. It assembles a whole from parts and passes nothing down automatically. Instantiation is simply creating one object from a class at runtime, which happens to every class, inherited or not. When a scenario describes a new class that should be a special kind of an existing class and automatically carry the parent's attributes, inheritance is the answer. Look for keywords like extends, derives from, or shared roles. Those are the signals. Question 3. An architecture team is choosing between two design approaches for a new banking application. One approach breaks the problem into sequential steps, while the other focuses on self-contained entities with their own data and behaviors. Which statement best describes the object-oriented approach? Your options are A. It breaks work into procedural functions. B. It focuses only on sequential steps. C. It avoids reusing code when possible. D. It centers on interacting self-contained objects. Before I reveal it, which one do you think is right? The correct answer is D. It centers on interacting self-contained objects. D is correct because object-oriented design produces solutions built from self-contained objects that combine data with operations. These objects interact to accomplish tasks, which differs significantly from the step-by-step approach of top-down design thinking. A is wrong because breaking work into procedural functions describes procedural programming, not object-oriented design. Procedural programming organizes code around tasks and functions rather than around objects that bundle both data and methods together. B is wrong because focusing only on sequential steps describes top-down design, which is the opposite approach. Object-oriented design organizes around objects and their interactions, not around the procedural flow of discrete sequential operations. C is wrong because avoiding code reuse contradicts one of the main advantages of the object-oriented approach. Object-oriented design actively promotes reusing code through classes and inheritance, saving development time and reducing potential errors significantly. Object-oriented programming is built on a simple but powerful idea. Instead of separating data from the functions that touch it, you bundle them together inside self-contained objects. Those objects then collaborate to get work done. Every object carries fields that store its state and methods that define what it can do. That boundary is the key insight. The rest of the program can only reach an object through its exposed methods, never by reaching directly into its data. Picture a banking application. The procedural version has a withdraw function, a deposit function, and a transfer function, all reaching into one shared pile of account records. The object-oriented version has account objects, customer objects, and transaction objects, each owning its own data and exposing a small set of methods that others can call. The classic contrast is object-oriented thinking against procedural and top-down design. Procedural and top-down approaches organize around functions and sequential steps. Object orientation organizes around what the program is made of, self-contained entities that own their data and behavior. When a question asks what best describes the object-oriented approach, look for phrases like bundle data with operations or interacting objects. Anything emphasizing sequential flow or step-by-step tasks is pointing toward procedural design instead. Question 4. A student is learning OOP and creates a dog class in Python. She then writes code to create a specific dog named Rex with brown fur and age 5. What best describes Rex in relation to the dog class she defined? Your options are: A. Rex is another separate class definition. B. Rex is an instance of the class. C. Rex is a method within the class. D. Rex is a parameter passed to class. What's your answer? Commit to one before I continue. The correct answer is B. Rex is an instance of the class. B is correct because an instance is a real usable object created from a class blueprint. Rex represents a specific dog built using the dog class template, making him an instance with actual values. A is wrong because a separate class definition would require writing a new blueprint entirely. Rex is not defining a new type of object, but is rather a concrete usable example built from the existing dog class. C is wrong because methods are functions defined inside a class that describe what objects can do. Rex is a specific object holding data like fur, color, and age, not an action or function within the class. D is wrong because a parameter is a variable listed in a method definition that accepts input values. Rex is a full object created from the class blueprint, not merely a placeholder value passed to a method. A class is just a blueprint, a description of what an object should look like. An instance is the real concrete object that gets built from that blueprint, filled with actual data. When the program runs a line that creates a new dog named Rex, the runtime allocates memory, fills in those fields, and produces a live object. That object is an instance. It has its own identity and its own copy of the data. Three things are often confused with an instance. The class is the general template, no real values, no memory. A method is a behavior defined inside the class, not an object. A parameter is an input slot in a method header, not a built object. The tell is always specificity. When a scenario hands you a named thing, Rex with brown fur and age 5, that is an instance. Real data values filling in the field names defined by the class is the marker that rules out class, method, and parameter. Anytime code creates a particular named object from a class, what exists in memory is an instance, not a new class, not a method, not a parameter. The presence of concrete filled-in values is the signal. Question 5. Inside a bank account class, a developer defines a balance variable that holds the current account total and a deposit operation that adds money into that balance. How should each of these two elements be correctly classified within the standard object-oriented programming terminology? Your options are: A. Both are methods of the class. B. Both are fields of the class. C. Balance is a field, deposit is a method. D. Balance is a method, deposit is a field. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is C. Balance is a field, deposit is a method. C is correct because a field is a variable inside a class that holds data or state, while a method is a function that performs actions. Balance holds data and deposit performs an operation. A is wrong because classifying both as methods ignores that balance stores a value rather than performing an action. Methods describe behaviors an object can execute, but balance is clearly data stored inside the account object. B is wrong because classifying both as fields misunderstands the role of deposit. Since deposit actively modifies the balance by performing an operation, it qualifies as a method rather than a passive data field. D is wrong because reversing the roles gets the definitions backwards entirely. Balance clearly stores numerical data and qualifies as a field, while deposit performs an action and therefore qualifies as a method instead. Inside a class, members fall into exactly two roles. Understanding which is the key to reasoning about how objects work. A field is a noun. It holds a value that persists inside the object between calls. A method is a verb. It runs only when invoked, performing work on that data. Together, these two roles make up every member of a class. Take a bank account class. The balance is a field. It sits in memory, holding the current total until something changes it. The deposit operation is a method. It runs when called, takes an amount, and adds it to the balance field. Apply the noun-verb test to any class member. If it stores state, a current value, a balance, a name, it is a field. If it executes logic, adds, calculates, changes something, well, it is a method. The rule never bends. No matter how a question is worded, the distinction stays the same. Fields and methods may also be called attributes and behaviors, but the underlying split is identical. A noun holds, a verb acts. Question 6. A programmer writes a recipe-style program that tells the computer exactly what to do line by line, using explicit instructions and variable assignments to solve a problem. This style of giving step-by-step commands to the machine best describes which programming paradigm? Your options are A. Imperative paradigm, B. Declarative paradigm, C. Functional paradigm, D. Logic paradigm. Which would you go with? Lock it in before the reveal. The correct answer is A. Imperative paradigm. A is correct because the imperative paradigm tells the computer exactly how to solve a problem through step-by-step instructions written in sequential order. Variables and assignments are central to this recipe-style programming approach. B is wrong because the declarative paradigm describes what the program should accomplish without specifying how to do it. This differs from giving explicit step-by-step commands, which is instead the hallmark of imperative programming style. C is wrong because functional programming is based on mathematical functions and avoids variables or assignment statements altogether. The scenario describes explicit variable assignment and sequential commands, which does not match the functional programming style. D is wrong because the logic paradigm works by defining facts and rules, then asking questions about them. It does not rely on step-by-step commands with variable assignments, but rather on inference over relationships. The imperative paradigm is one of the oldest and most fundamental styles of programming. Rather than describing what you want, imperative code tells the computer exactly how to do it, step by step. Every imperative program is built from three essentials. Assignment stores values in name variables. Control structures like loops and conditionals decide what runs. And mutable state, values that change over time, carries the program's meaning forward. Picture a routine that totals a list of numbers. It starts with sum set to 0, loops through each item and adds it to sum on every pass. Each line is an explicit command that changes state. Nothing merely describes the desired result. The sharpest contrast is with the declarative style. Imperative code specifies how, every move spelled out. Declarative code specifies what and leaves the how to the system. Functional and logic programming both fall on the declarative side. When you see step-by-step instructions, variables being assigned, and state changing in order, that is the imperative paradigm. Procedural and object-oriented code are both imperative at heart. Wat sie bis band. They still run ordered, state-changing statements. Question 7. A data scientist chooses a language like Lisp or Scheme for a project that requires mathematical reliability and unchanging data throughout execution. The chosen language builds programs entirely by calling functions without using variables or assignment statements. Which paradigm does this match? Your options are A. Imperative paradigm, B. Procedural paradigm, C. Logic-based paradigm, D. Declarative functional paradigm. Don't overthink it. Which one feels right? The correct answer is D. Declarative functional paradigm. D is correct because the declarative functional paradigm relies on mathematical functions to compute results and avoids variables or assignment statements. Languages like Lisp, Scheme, and ME are well-known examples of this programming approach. A is wrong because the imperative paradigm relies heavily on variables, assignments, and step-by-step state changes. This conflicts directly with the scenario described, where no variables or assignment statements are used during program execution. B is wrong because the procedural paradigm groups instructions into functions performing specific tasks, but still uses variables and assignments extensively. It is a subset of imperative programming, not the mathematical function approach described in the scenario. C is wrong because the logic-based paradigm works through facts, rules, and inference using languages like Prolog. It does not center on calling mathematical functions to compute results, which is specifically the functional approach instead. Functional programming is a paradigm where computation is built entirely from mathematical functions, no step-by-step instructions, no variables being reassigned, just inputs flowing into outputs. Functional programs share 4 defining traits: pure functions, immutable data, no assignment statements, and recursion in place of mutable loops. Together, these make every function call predictable and provable. Think of it the way a mathematician nests formulas. The result of f of g of h of x is determined entirely by x. Meki kam kietsi. Nothing hidden changes underneath, and you can always substitute the expression with its value. This property is called referential transparency. Because a pure function touches no shared state and produces no side effects, you can replace any call with its result, making bugs caused by hidden mutation impossible. The decisive clue separating functional from procedural is state. Procedural code, even with functions, and it still reassigns variables and mutates state. Functional code does not. Languages like Lisp, Scheme, and ML were built around this mathematical reliability from the ground up. Question 8. A researcher is building an expert system that needs to infer answers from a set of stored facts and rules about medical diagnoses. Instead of writing step-by-step instructions, the researcher defines relationships and asks questions. Which paradigm best supports this approach? Your options are A. Imperative paradigm using BASIC, B. Declarative logic paradigm using Prolog, C. Object-oriented paradigm using Java, D. Procedural paradigm using Pascal. Got a guess? Lock it in. The correct answer is B. Declarative logic paradigm using Prolog. B is correct because the declarative logic paradigm is based on facts and rules rather than explicit instructions. Prolog is the classic example language used for expert systems requiring inference and reasoning over stored knowledge. A is wrong because BASIC is an imperative language that requires step-by-step instructions with variables and assignments. It does not naturally support inference over facts and rules, which is what the expert system in this scenario requires. C is wrong because Java is an object-oriented language focused on objects, methods, and inheritance. It does not specialize in logical inference from facts and rules, which makes Prolog far better suited for the expert system described. D is wrong because Pascal supports procedural programming with functions and step-by-step logic. It does not have built-in mechanisms for automatic inference over facts and rules, which are central to the logic programming paradigm approach. Logic programming is a declarative style where you describe knowledge as facts and rules, then let the system do the reasoning. Instead of writing step-by-step instructions, you state what is true and pose a query. Every logic program has three building blocks: facts, which are plain assertions about the world; rules, which derive new truths from existing ones; and queries, which ask the inference engine to prove something. When a query arrives, the inference engine searches the facts and rules, backtracking whenever a path fails and trying another route. The programmer never writes the search loop. It happens automatically. Logic programming sits in the declarative family alongside functional programming, but its native model is inference over relationships, something imperative, procedural, and object-oriented approaches were not built for. Whenever a scenario involves building an expert system, defining relationships, and querying for answers, with Prolog as the language, that is the logic paradigm at work. Question 9. A developer is maintaining a legacy accounting system written in C, where the program is organized into smaller related functions that each handle specific tasks, like tax calculation and report printing. This grouping of instructions into task-specific functions best describes which paradigm? Your options are A. Procedural paradigm, B. Functional paradigm, C. Object-oriented paradigm, D. Logic paradigm. Which one is it? Pause the video if you need more time. The correct answer is A. Procedural paradigm. A is correct because the procedural paradigm breaks programs into smaller functions, each performing a specific task. Related instructions are grouped together logically, which is exactly the style seen in languages like C, Pascal, and BASIC. B is wrong because the functional paradigm centers on mathematical functions without using variables or assignments at all. While it also uses functions, its strict mathematical rules differ from the loose task grouping style seen in procedural C code. C is wrong because the object-oriented paradigm bundles data and behaviors into objects with fields and methods. The scenario describes grouping instructions into functions, not wrapping data and behavior together inside reusable object blueprints. D is wrong because the logic paradigm defines relationships through facts and rules, then uses inference to answer queries. The scenario involves executing specific computational tasks through functions, which does not match logic programming at all. Procedural programming is a way of organizing code by grouping related instructions into named, reusable blocks called procedures, functions, or subroutines. These functions each handle a specific task and are called as needed from a central routine. Execution begins in a main routine, which calls other functions in turn. Data moves between them through parameters, and each function can be called from multiple places, reducing duplication and keeping changes localized. Procedural is most easily confused with functional programming because both use functions. The key split is state. Procedural functions freely assign and mutate variables, while functional functions avoid assignment entirely. Object-oriented design differs further by bundling data and behavior inside objects rather than standalone functions. When reading a scenario, watch for programs split into task-specific functions that pass data through parameters and freely update shared variables, with no objects in sight. Languages like C, Pascal, and BASIC are classic homes of this paradigm. Remember, if the design groups instructions into name task functions that share and mutate state, the label is procedural, not functional, not object-oriented. Question 10. A development team is comparing two tools. Tool A translates the entire source code into machine code before execution, while Tool B executes source code line by line in real time. Which statement correctly identifies these two tools in this comparison? Your options are A is interpreter, B is compiler. B, both tools function as interpreters only. C, A is compiler, B is interpreter. D, both tools function as compilers only. Take a second. Which answer would you pick? The correct answer is C. A is compiler, B is interpreter. C is correct because A compiler translates source code into machine code before execution, producing an executable file. An interpreter executes source code directly and translates statements in real time, typically running slower than compilers. A is wrong because reversing the roles gets both definitions backwards. A compiler translates code before execution, while an interpreter translates and executes statements in real time. So Tool A matches the compiler description instead. B is wrong because classifying both as interpreters ignores that Tool A translates the entire source code before execution begins. That pre-execution translation is the defining behavior of a compiler, not an interpreter tool. D is wrong because classifying both as compilers misses that Tool B executes source code line by line in real time. Real-time statement translation during execution is the hallmark of an interpreter, not a compiler. Every program written in a high-level language must be translated into machine instructions before the hardware can run it. Two classic strategies handle that translation: compiling and interpreting. A compiler reads the entire source, translates it all ahead of time, and produces a standalone executable. An interpreter reads one statement, translates it, runs it, then moves to the next. Translation and execution happen together. The compiler's output, the executable, runs independently and without the compiler present. The interpreter must be present every single time the program runs because it is doing the translation live. When a question describes translating the whole program before it runs and producing an executable, that signals a compiler. When it describes executing source line by line in real time, that signals an interpreter. The timing of translation is the deciding fact. Compilers front-load all translation for speed and portability. Interpreters spread it across execution for flexibility and fast turnaround. The only thing that separates them is when the work gets done. Question 11. A developer is building an undo feature for a text editor, where the most recent action must be reversed first. The developer needs a data structure that removes the last item added before any older items. Which data structure best fits this requirement? Your options are a queue following FIFO order, B, array with fixed indexing, C, linked list with node references, D, stack following LIFO order. Before I reveal it, which one do you think is right? The correct answer is D, stack following LIFO order. D is correct because a stack organizes data using the last in first out principle, meaning the most recent item added is the first one removed. This perfectly matches the undo feature requirement in the text editor described. A is wrong because a queue follows first in first out order, where the oldest item is removed first. This is the opposite of what the undo feature needs, since undo must reverse the most recent action first. B is wrong because an array allows fixed indexing into a contiguous memory block but does not enforce any order of removal. The developer needs strict last in first out behavior, which arrays alone do not naturally provide here. C is wrong because a linked list offers flexibility in insertion and deletion through node references, but does not enforce the last in first out discipline by itself. A stack is the specific structure built for this access pattern. A stack is an abstract data type built around one simple rule. The most recently added item is always the first one removed. This principle is called last in, first out, or LIFO. All stack activity happens at one end, the top. Push places a new item there and pop removes it. The rest of the items simply wait below, inaccessible until everything above them is removed first. Stacks expose just 3 operations. Push adds an item to the top, pop removes it, and peek reads the top value without taking it off. There is deliberately no way to reach into the middle. The everyday image is a cafeteria tray stack. The last tray set down sits on top and is the first one taken. That same discipline, newest out first, is exactly what programmers use stacks for undo histories, nested expressions, and function call tracking. The classic trap is confusing a stack with a queue, array, or linked list. A queue serves the oldest item first, the opposite of a stack. Arrays allow access anywhere, and linked lists impose no removal order at all. Only the stack guarantees the newest item leaves first. Question 12. A customer service application processes support tickets strictly in the order they were submitted, so the first ticket received must get answered before any ticket submitted later on. The earliest entry must always leave the system first. Which data structure correctly models this workflow? Your options are A. Stack with push and pop, B. Queue using FIFO ordering, C. Array accessed by random index, D. Hash table with key lookup. What's your answer? Commit to one before I continue. The correct answer is B. Queue using FIFO ordering. B is correct because a queue follows first in, first out ordering, where elements added first are removed first. This matches the support ticket workflow exactly, just like a grocery store line serving the earliest customer first. A is wrong because a stack uses last in, first out ordering, which would process the newest ticket first instead of the oldest one. This reversed order contradicts the fair first come first served workflow the customer service team requires here. C is wrong because random index access on an array does not preserve any particular processing order across entries. Without enforced ordering, tickets could be handled out of sequence, violating the fairness the application requires. D is wrong because a hash table uses keys to look up values quickly, but does not inherently preserve insertion order. This structure optimizes lookups, not sequential first submitted processing of items as the scenario requires. A queue is an abstract data type built on one core promise. The item that arrives first is always served first. Unlike a stack which flips order, a queue preserves the exact sequence of arrival. A queue exposes just 2 operations. OnQueue adds a new item at the back, and DQ removes the oldest item from the front. Each runs in constant time, and access is deliberately restricted to these 2 ends. The grocery checkout is the classic image. The shopper who arrived first reaches the register first, and every new arrival joins the back. This is exactly the first come first served discipline that queues enforce in software. The most common trap is confusing a queue with a stack, which serves the newest item first, or with arrays and hash tables. Arrays allow random index access, and hash tables offer fast key lookups, but neither enforces leave an arrival order the way a queue does. Whenever a problem describes processing items in arrival order, what kies hy for intake? Tickets, print jobs, requests. That is a queue. The phrases first in, first out, oldest first, and order received are your signals. Question 13. An analyst is choosing between two data structures. Structure X holds 100 student IDs, all of the same integer type, while structure Y groups a student's name, birth date, and GPA together under one identifier. Which classification correctly describes each structure? Your options are A. X is an array, Y is a record. B. X is a record, Y is an array. C. Both X and Y are records. D. Both X and Y are arrays. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is A. X is an array, Y is a record. A is correct because an array stores items of the same data type in a contiguous memory block accessed by index. A record groups heterogeneous items of different types under one name, matching the scenario exactly. B is wrong because reversing the classifications gets both definitions backwards. Structure X holds identical integer types, which matches array behavior, while structure Y groups mixed data types under one name, which matches record behavior instead. C is wrong because classifying both as records ignores that structure X contains only identical integer values of the same type. Records specifically group heterogeneous items of different types, so structure X does not fit that definition. D is wrong because classifying both as arrays ignores that structure Y contains mixed data types like name, date, and GPA values. Arrays require all elements to share the same type, which rules out structure Y entirely. Arrays and records are both ways to group data under a single name, but they solve fundamentally different problems. Understanding what separates them is the key to identifying each structure correctly. An array holds many items of the same type arranged in order and accessed by a numeric index. Every element is identical in type, stored contiguously in memory, so reaching any one by position takes constant time. A record instead bundles several attributes of possibly different types under one identifier, each reached by a field name rather than a number. It represents one compound entity, like a student with a name, a birth date, and a grade point average. Visually, an array looks like a uniform row of identical slots addressed by number. A record looks like a labeled bundle of differently sized compartments, each named for the attributes it holds. When identifying structures under pressure, ask two questions. Do the grouped items share one type and use an index? Or do they carry mixed types under field names? Homogeneous and positional means array. Heterogeneous and labeled means record. Question 14. A programmer needs a data structure where each element points to the next element in the sequence, allowing easy insertion and deletion without shifting memory positions around. The collection should consist of nodes connected by references. Which data structure best matches this description? Your options are A. Contiguous array with index. B. Stack using push and pop. C. Linked list of connected nodes. D. Record with name fields. Which would you go with? Lock it in before the reveal. The correct answer is C. Linked list of connected nodes. C is correct because a linked list is a collection of elements where each node contains a reference pointing to the next node. This structure permits efficient insertion and deletion without requiring memory reorganization after changes. A is wrong because a contiguous array stores items in adjacent memory blocks accessed by index. Insertion and deletion can require shifting many elements to maintain contiguous storage, which contradicts the requirement for efficient modifications. B is wrong because A stack restricts access to only the top of the structure through push and pop operations. It does not naturally support insertion in the middle of the collection, which linked lists handle well. D is wrong because A record groups related but different data types under one name, representing a single compound entity. It is not a sequential collection of nodes connected by references the way a linked list is. A linked list is a data structure where each node holds data and a reference pointing to the next node in the sequence. Unlike an array, nodes aren't stored side by side in memory. They're chained together by those references. The list begins at the head node and walks the chain through every element until the last node, whose reference points to null, signaling the end of the list. The core advantage of a linked list is that insertion and deletion are cheap. Adding or removing a node only requires a couple of references, no surrounding element shift in memory. Compare this to an array, which offers fast index access but pays for mid-list changes with shifting. A stack restricts access to one end, and a record bundles named fields. Neither chains nodes with references the way a linked list does. When a problem describes elements pointing to the next, nodes connected by references, or efficient insertion and deletion without reorganizing memory, that's your signal. You're looking at a linked list. Question 15. A computer science instructor explains that certain programming concepts are templates or blueprints, defining what operations can be performed on data without specifying implementation details. These concepts are also called containers because they hold data. What term describes these concepts? Your options are A. Raw data types like integer, B. Physical memory addresses, C. Machine code instructions, D. Abstract data types. Don't overthink it. Which one feels right? The correct answer is D. Abstract data types. D is correct because an abstract data type is a template defining how to organize and use data along with permitted operations. Lists, stacks, and queues are examples, and they are commonly called containers because they hold data. A is wrong because raw data types like integer, float, and character describe basic building blocks for storing single values. They are not the higher level organizational templates defining permitted operations on collections of data elements. B is wrong because physical memory addresses refer to actual hardware locations where data is stored. They describe where data lives in the machine, not the conceptual templates for organizing data and permitted operations on it. C is wrong because machine code instructions are low-level binary commands directly executed by the processor. They are not blueprints for organizing data and its permitted operations, but rather the final executable form of compiled programs. An abstract data type defines a data structure by what it does, not how it's built. It specifies the data held and the operations allowed while hiding every implementation detail. An ADT is a contract. It names the data it organizes, the operations callers may use, and deliberately says nothing about memory layout. Because ADTs hold and organize collections, they are commonly called containers. The three classic containers are the stack with push and pop in last and first out order, the queue with NQ and DQ in first out order, and the list with ordered insertion and removal. Each is defined entirely by these operations. Because the ADT only specifies operations, a stack built on an array and one built on a linked list are completely interchangeable. Any code that only calls push and pop keeps working regardless of what sits underneath. It is important to distinguish ADTs from lower level concepts. A raw data type like an integer stores a single value. A memory address names a physical hardware location. Machine code is executable processor instructions. The abstract data type sits above all of these as the conceptual model that defines a collection through its operations alone. Question 16. A developer needs to find a customer record inside a massive sorted database of 1 million entries. The developer wants the fastest possible search that repeatedly divides the search space in half until the target is found. Which algorithm best fits this requirement? Your options are A. Sequential search algorithm, B. Binary search algorithm, C. Bubble sort algorithm, D. Selection sort algorithm. Got a guess? Lock it in. The correct answer is B. Binary search algorithm. B is correct because binary search repeatedly divides a sorted list in half to locate a target value quickly. It works only on sorted lists and is dramatically faster than sequential search on large data sets like this. A is wrong because sequential search checks each element one by one from start to end until finding the target. While it works on unsorted lists too, it is far slower than binary search on massive sorted data sets. C is wrong because bubble sort is a sorting algorithm, not a search algorithm. It repeatedly compares adjacent elements and swaps them when out of order, but it does not locate a specific target value in a list. D is wrong because selection sort is a sorting algorithm that repeatedly finds the minimum element in the unsorted portion. It arranges items in order, but does not perform the search operation the developer actually needs here. Binary search is a powerful algorithm for locating a target value in a sorted list. Instead of checking every element one by one, it eliminates half the remaining candidates with each single comparison. Each step follows the same pattern. Examine the middle element, decide which half cannot contain the target, discard it, and repeat. The boundaries close in until the target is found or the range is empty. The algorithm tracks a low and high boundary. It examines the midpoint between them, then shifts whichever boundary discards the wrong half. This is why sorted order is essential. The ordering tells the algorithm which half to keep. Binary search is often confused with sequential search, which checks every element in order and works on unsorted data but is slow on large lists. It is also confused with bubble sort and selection sort, which arrange data rather than find a specific value. They search nothing. Whenever a question describes repeatedly dividing a sorted list in half to locate a target as fast as possible, that is binary search. The sorting precondition is the price. Dramatic speed on large data sets is the reward. Question 17. A library clerk is searching through an unorganized pile of return slips to find a specific book title. She checks each slip one at a time from top to bottom until the target appears. Which searching algorithm does this manual process resemble? Your options are A. Sequential or linear search, B. Binary search over sorted, C. Quick sort with pivot, D. Hash-based direct lookup. Which one is it? Pause the video if you need more time. The correct answer is A. Sequential or linear search. A is correct because sequential search, also called linear search, checks each element in a list one by one from start to end until finding the target. It works on any list, sorted or not. B is wrong because binary search requires the list to be sorted before it can work. The scenario describes an unorganized pile of slips, so binary search cannot function properly without first sorting the entire pile. C is wrong because quicksort is a sorting algorithm that uses a pivot to divide and sort recursively. It organizes items but does not perform a search for a specific target value in an existing collection. D is wrong because hash-based direct lookup uses a key to compute the location of an item instantly. The scenario describes sequential manual checking, not a direct computed lookup, so hash lookup does not apply here. Sequential search, also called linear search, works by examining each element of a list one at a time, from the very first to the last, until the target is found or the list runs out. It makes no assumptions about order, so it works on any list, sorted or unsorted. The algorithm starts at the first element and compares it to the target. If they match, the search stops successfully. If not, it moves to the next element and repeats. continuing all the way to the end if necessary. Sequential search is the right choice in 3 situations: when data is unsorted and no shortcut exists, when lists are small enough that sorting first would cost more than it saves, and whenever you simply need a method that always works. It helps to contrast sequential search with its common mix-ups. Binary search is faster but demands sorted data. Sorting algorithms rearrange elements rather than locate them. Hash lookups jump directly to a computed position. Sequential search is the plain order-agnostic scan, slower on large data but universally applicable. Whenever you see clues like one at a time, from the beginning, or unsorted collection, you are looking at sequential search. Its strength is universality. Its trade-off is speed on large lists. Question 18. A beginner programmer writes a sorting routine that walks through a list repeatedly, comparing each pair of adjacent elements and swapping them whenever the first is larger than the second. This continues until the list is fully sorted. Which algorithm is this? Your options are A. Quick sort, B. Radix sort, C. Bubble sort, D. Binary search. Take a second. Which answer would you pick? The correct answer is C. Bubble sort. C is correct because bubble sort repeatedly moves through a list, comparing adjacent elements and swapping them when they are in the wrong order. It is simple to implement but slow for large lists of items. A is wrong because quicksort uses a pivot to divide the list into parts and sorts each part recursively. It does not rely on repeatedly comparing and swapping adjacent pairs across the entire list, like bubble sort. B is wrong because Radix sort groups numbers by each digit place and processes all digit places to sort. It does not compare adjacent elements pairwise, but rather distributes items into buckets based on digit values. D is wrong because binary search is a searching algorithm, not a sorting algorithm at all. It locates a target value in a sorted list by halving the search space, which is completely different from sorting. Bubble sort is one of the most fundamental sorting algorithms, and understanding it reveals the core logic shared by all sorting strategies. Let's look at what makes bubble sort unique. The algorithm walks the list from left to right, comparing each pair of neighboring elements. Whenever the left element is larger than the right, the two are swapped. After one full pass, the largest value has drifted all the way to the end, just like a bubble rising to the surface. Each pass through the list does 3 things: compare neighboring elements, swap them if the left is larger, and guarantee the biggest remaining value lands at the far right. Repeated passes sort the rest of the list, 1 value per pass. It is easy to confuse bubble sort with quick sort, insertion sort, or selection sort. Quick sort partitions around a pivot. Insertion sort grows a sorted region. Selection sort repeatedly picks the minimum. Only bubble sort is defined entirely by swapping adjacent out-of-order neighbors, pass after pass. Whenever you see a routine that compares neighboring elements, swaps them when out of order, and repeats until no swaps are needed, that is bubble sort. Its simplicity makes it the classic first sorting algorithm every programmer meets. Question 19. A senior engineer is choosing a sorting algorithm for a large unsorted data set with millions of records. She needs an algorithm that selects a value to split the list into parts and sorts each part recursively, offering strong performance on large lists. Which algorithm fits? Your options are A. Bubble sort with adjacent swaps, B. Selection sort with minimum pick, C. Insertion sort one at a time, D. Quick sort using pivot recursion. Before I reveal it, which one do you think is right? The correct answer is D. Quick sort using pivot recursion. D is correct because quick sort uses a pivot value to divide the list into parts. then sorts each part recursively through repeated partitioning. It is very fast for large lists, but more complex to implement properly. A is wrong because bubble sort repeatedly swaps adjacent elements, which is simple but performs poorly on large data sets. It does not use a pivot or recursive partitioning strategy and runs much slower than quicksort here. B is wrong because selection sort repeatedly finds the minimum element in the unsorted portion and moves it to the beginning. While simple, it is slow on very large lists and does not use pivot-based recursion. C is wrong because insertion sort builds the sorted array one item at a time by placing each item in correct position. It is faster than bubble sort, but still slower than quicksort on massive unsorted datasets. Quicksort is a powerful sorting algorithm built around a single clever idea. Pick a value, split the list around it, and repeat. Understanding why it works so well means understanding divide and conquer recursion. The algorithm selects a pivot element, then rearranges the list so every smaller value lands to its left and every larger value to its right. This single sweep places the pivot in its exact final sorted position. Every pass through the data follows 3 steps. Pick a pivot, partition around it, then recursively apply the same procedure to the left and right halves. Recursion bottoms out when a partition has one element or none. None of the simpler sorts use a pivot or recursion. Bubble sort swaps adjacent pairs. Selection sort repeatedly pulls out the minimum, and insertion sort grows a sorted region one item at a time. Only quicksort splits the data around a chosen value. Whenever you see a scenario involving pivot-based partitioning and recursive halving, some states, especially for large data sets, that signature belongs to quicksort. Speed on large lists is its defining advantage over simpler, slower neighbors. Question 20. A card player picks up cards one at a time from the table and immediately places each new card into its correct position among the cards already in her hand. Which sorting algorithm does this everyday behavior most closely resemble? Your options are A. Insertion sort, B. Radix sort, C. Quicksort, D. Bubble sort. What's your answer? Commit to one before I continue. The correct answer is A. Insertion sorts. A is correct because insertion sort builds the final sorted array one item at a time by inserting each new item into its correct position. This matches the card playing analogy where cards are placed into their proper spots immediately. B is wrong because Radix sort groups numbers by each digit placed across multiple passes until fully sorted. It processes items in batches by digit value, which does not match the one-at-a-time insertion behavior described in the scenario. C is wrong because quicksort uses a pivot to divide the list recursively, not a one-at-a-time insertion approach. The card player does not split the cards into groups around a pivot value as quicksort requires. D is wrong because bubble sort walks through the list repeatedly, comparing and swapping adjacent elements. The card player does not repeatedly compare neighboring cards throughout the hand, but rather places each new card directly into position. Insertion sort builds a sorted list one element at a time, always growing a sorted region from the left. Understanding how it works and how it differs from other algorithms makes it easy to recognize in any context. The algorithm treats the leftmost element as a sorted region of 1. With each step, it takes the next unsorted element and slides it backward through the sorted region, shifting larger elements right until it lands in exactly the right spot. The classic analogy is a card player. Each newly drawn card is inserted directly into its correct position among cards already held in order. A 7 slides between the 6 and 8, a 2 goes straight to the front. The hand stays sorted as it grows. Insertion sort is frequently confused with its neighbors. Bubble sort repeatedly swaps adjacent pairs across the whole list. Quicksort splits around a pivot and recursors. Radix sort distributes items into buckets by digit value. Only insertion sort grows a sorted region by dropping each next element directly into place. The markers to watch for are phrases like one at a time, insert into position, and already sorted portion, especially paired with a card game image. That combination points to insertion sort and nothing else. Question 21. A math professor teaches her students a classic 4-step systematic approach for tackling complex problems. First, understand the problem, then devise a plan, execute the plan carefully, and finally review the solution. Which well-known problem-solving method is the professor teaching her students here? Your options are A. The SDLC 7-step cycle, B. The OP brainstorming approach, C. George Polya's problem-solving method, D. The waterfall development model. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is C. George Polya's problem-solving method. C is correct because George Polya's problem-solving method consists of 4 key steps: understanding the problem, devising a plan, executing the plan, and reviewing the solution. The mnemonic UDA helps students remember the sequence easily. A is wrong because the SDLC 7-step cycle covers software development from understanding the problem through maintenance. While it shares some concepts, it has 7 specific steps rather than the 4 general steps Polya defined. B is wrong because the OP brainstorming approach is part of a decomposition process including filtering, scenarios, and responsibility algorithms. It applies specifically to object-oriented design rather than the general problem-solving method Polya defined. D is wrong because the waterfall development model describes a linear software process with distinct phases like requirements and design. It focuses on software delivery phases rather than the general 4-step problem-solving approach taught by Polya. George Polya was a mathematician who created a 4-step framework for tackling any complex problem in an orderly way. His method became a universal template far beyond mathematics. The 4 steps are understand, devise, execute, and review, remembered by the mnemonic UDA. Each step has a distinct role. Understanding pins down what is known and unknown. Devising selects a strategy. Executing carries it out carefully. And reviewing checks whether the result actually solves the problem. Polya's framework exists because people naturally leap at solutions before fully grasping the problem. By forcing an explicit understanding step first and a review step last, the method catches misreadings early and verifies results at the end. Polya's 4 general steps are often confused with more specialized frameworks. The software development lifecycle and the computer problem-solving process are software-specific and have many more stages. Object-oriented decomposition is a design methodology for identifying classes. Polya's method sits upstream of all of them as the broad template the others adapt. When a scenario describes exactly 4 steps, understand, plan, execute, and review, attributed to a mathematician. That is Polya's method. The count of 4 general steps and the mnemonic UDA are the identifying markers. Question 20. A software engineering team is working through the standard software development lifecycle. After understanding the problem and planning the logic, the team has coded the program and used an interpreter to translate it. What should the team logically do next according to the standard sequence? Your options are A. Put program into production immediately. B. Test the program for correctness. C. Begin maintaining the finished program. D. Return to planning the logic. Which would you go with? Lock it in before the reveal. The correct answer is B. Test the program for correctness. B is correct because the standard SDLC sequence moves from translating the code directly to testing the program. Testing must occur before putting the program into production to catch any logic errors or functional defects first. A is wrong because putting the program into production before testing risks deploying untested and potentially broken code. The SDLC requires a testing phase between code translation and production deployment, so this step comes later in sequence. C is wrong because maintenance is the final phase of the SDLC and happens after the program is already in production. Beginning maintenance before testing and deployment completely skips essential phases required by the standard life cycle. D is wrong because returning to planning the logic would mean going backwards in the life cycle without justification. After coding and translation, the next step forward is testing, not revisiting earlier phases of the development cycle. The software development life cycle is the ordered sequence of phases every software project moves through from first idea to long-term maintenance. The order is deliberate. Each phase depends on the one before it. The cycle moves from understanding the problem and planning the logic through coding and translation into testing, then production, and finally ongoing maintenance. Translation comes before testing, and testing always comes before production. That ordering is the whole point. Skipping or reordering phases is exactly what the life cycle exists to prevent. Teams that jump straight to coding or deploy without testing ship defects to real users. Maintenance is not an afterthought. It is a recognized continuous phase. Once source code is written, a compiler or interpreter translates it into a runnable form. That runnable program is then tested with sample inputs to verify correctness. Only after testing confirms the program works does it move into production. Deploying before testing inverts the safeguard the life cycle is built to enforce. Whenever a question asks what comes right after translation, the answer is testing. Not deployment, not maintenance, not planning. That sequence is the discipline the life cycle is designed to enforce. Question 23. A project manager assigns her developer the task of solving a complex scheduling problem by breaking it down into progressively smaller steps and tasks until each piece becomes simple enough to implement individually. Which design methodology best describes a structured approach? Your options are A. Object-oriented decomposition, B. Functional paradigm method, C. Responsibility algorithm approach, D. Top-down design method. Don't overthink it. Which one feels right? The correct answer is D. Top-down design method. D is correct because top-down design solves problems by breaking them down into smaller steps or tasks progressively. Each piece is refined until it becomes simple enough to implement directly, building up to the full solution step by step. A is wrong because object-oriented decomposition produces solutions based on self-contained objects composed of data and operations. It focuses on modeling interacting entities rather than successively breaking a problem into smaller procedural steps or tasks. B is wrong because the functional paradigm method uses mathematical functions without variables or assignments to compute results. It is a programming style rather than a general design methodology for systematically decomposing complex problems into smaller steps. C is wrong because the responsibility algorithm approach is one stage within object-oriented design methodology involving brainstorming and filtering. It is not a standalone design strategy for breaking complex problems into smaller sequential steps and subtasks. Top-down design is a problem-solving methodology that starts with the whole problem and progressively breaks it into smaller and smaller pieces. Rather than tackling a complex task all at once, you work from the general down to the specific, level by level, until every piece is simple enough to implement directly. The result is a tree of tasks. The full problem sits at the top. Major subtasks branch from it, and each subtask that is still too complex gets split again. This continues until every bottom-level piece is small enough to code in a single routine. The process follows 3 repeating steps. State the overall task, divide it into major subtasks, then refine any piece that is still too complex by splitting it again. This continues level by level until every remaining task is simple and direct. Top-down design is often confused with 3 other approaches. Object-oriented decomposition models interacting objects with data and behavior. The functional paradigm builds programs from mathematical functions. The responsibility algorithm stage is just one phase inside object-oriented design. Only top-down design is defined by successively splitting a problem into smaller procedural tasks. Whenever you see language like breakdown, smaller steps, refine, or stepwise, and the pieces being split are tasks rather than objects, that is top-down design at work. Question 25. A computer science student is learning the 4 stages of the computer problem-solving process used specifically for software projects. These stages cover the entire journey from understanding requirements through long-term care of the finished product. Which sequence correctly lists all 4 stages? Your options are A. Analysis, algorithm, implementation, maintenance. B. Testing, deployment, monitoring, retirement. C. Brainstorming, filtering, scenarios, responsibilities. D. Understand, plan, execute, review. Got a guess? Lock it in. The correct answer is A. Analysis, algorithm, implementation, maintenance. A is correct because the 4 stages of the computer problem-solving process are analysis and specification, algorithm development, implementation, and maintenance. This framework specifically adapts general problem-solving to the needs of software projects and systems. B is wrong because testing, deployment, monitoring, and retirement describe parts of a software operations lifecycle, but not the 4 named stages of the computer problem-solving process. The official stages focus on earlier development activities instead. C is wrong because brainstorming, filtering, scenarios, and responsibilities are stages within the object-oriented decomposition methodology. They apply to designing OOP solutions rather than to the broader 4-stage computer problem-solving process framework in general. D is wrong because understand, plan, execute, and review are the 4 steps of George Polier's general problem-solving method. While related and influential, these are not the specific 4 stages defined for the computer problem-solving process. The computer problem-solving process is a 4-stage framework designed specifically for software projects. Unlike general problem-solving, it follows a product from its very first requirements all the way through years of ongoing care. The 4 stages are analysis and specification, algorithm development, implementation, and maintenance. Analysis pins down what the software must do. Algorithm development designs the logic. Implementation turns that design into tested working code. Maintenance then keeps the system healthy and current after release. Each stage feeds into the next. The process is linear, but the maintenance stage creates a long tail, often the costliest phase, where defects are fixed and the system adapts as business needs change. This process is often confused with Polier's 4-step method and object-oriented decomposition. Polier's steps are universal and stop once a solution is found. Object-oriented decomposition focuses on design methodology. The computer problem-solving process is the only framework that formally names maintenance as its own stage. When you see 4 software-focused stages spanning requirements through long-term upkeep, that is the computer problem-solving process. The presence of maintenance as a named formal stage is its strongest identifier. Question 25. A team lead is applying a structured decomposition process to design a new object-oriented inventory system. The process includes brainstorming possible classes, filtering out unnecessary ones, walking through scenarios, and then defining responsibility algorithms. What is the main purpose of the structured methodology? Your options are A. Translate code into machine language. B. Search sorted lists for values. C. Produce well-structured object-oriented development. D. Replace testing in the SDLC. Which one is it? Pause the video if you need more time. The correct answer is C. Produce well-structured object-oriented development. C is correct because the four-stage decomposition process of brainstorming, filtering, scenarios, and responsibility algorithms exists specifically to produce a well-structured, object-oriented development process. It ensures classes and their responsibilities are thoughtfully identified before coding. A is wrong because translating code into machine language is the role of compilers or interpreters during the SDLC. It is a technical tool function rather than a design methodology for structuring object-oriented solutions at the concept level. B is wrong because searching sorted lists for values describes what algorithms like binary search accomplish. It has no relationship to the object-oriented design decomposition methodology involving brainstorming and filtering stages for class identification. D is wrong because testing remains an essential phase of the SDLC regardless of which design methodology is used. Object-oriented decomposition supplements design activities but does not replace testing or any other required lifecycle phase. Object-oriented decomposition is a structured methodology for deciding which classes a system needs and what each one is responsible for before a single line of code is written. Without a deliberate process, jumping straight to coding tends to produce tangled, poorly chosen objects. Decomposition forces designers to think before they build. The methodology moves through four stages: brainstorming every candidate class, filtering out redundant or unnecessary ones, walking through scenarios to validate collaboration, and writing responsibility algorithms that define how each class fulfills its duties. In practice, a team might brainstorm classes like product, supplier, and order, then filter and merge overlaps, walk through a shipment scenario to catch missing pieces, and finally document how each class does its job. Whenever you see brainstorming, filtering, scenarios, and responsibility algorithms described together, that is object-oriented decomposition, distinct from top-down design, the computer problem-solving process, or any compiler or testing role. Question 26. A new computer technician is explaining to a customer what makes her computer actually usable. She describes a piece of software that manages hardware resources, provides a user interface, and coordinates how applications access the computer's components. Which piece of software is she describing? Your options are A. Operating system, B. Word processor, C. Web browser, D. Antivirus program. Take a second. Which answer would you pick? The correct answer is A. Operating system. A is correct because the operating system is the main software that manages hardware and software resources, provides services to programs, and offers a user interface. Only one operating system runs the computer at a time normally. B is wrong because a word processor is application software designed for creating and editing text documents. It relies on the operating system to access hardware and does not itself manage the computer's resources or coordinate applications. C is wrong because a web browser is application software for viewing web pages and navigating the internet. It does not manage hardware resources or provide the user interface that allows applications to access computer components directly. D is wrong because antivirus programs are specialized application software that scan for and remove malicious code. They operate on top of the operating system, rather than performing the foundational resource management the customer needs explained here. The operating system is the foundational software layer that sits between raw hardware and every program you run. Without it, no application could function. It would have to manage the processor, memory, and devices entirely on its own. The OS exists because centralizing resource management eliminates enormous duplication of effort. It allocates the processor, memory, and storage fairly among programs, shields applications from low-level hardware details, and gives users a consistent way to work. Think of the operating system as a middle layer. Hardware sits at the bottom. The OS sits above it, managing everything, and applications run on top, requesting services from the OS rather than ever touching hardware directly. The OS has 5 core responsibilities: managing processors, managing memory, managing files and storage, managing devices through drivers, and providing a user interface, whether a command line or a graphical desktop. A word processor, browser, or antivirus tool are applications. They run on top of the OS and rely on it to reach hardware. Only the operating system owns the machine's resources, coordinates programs, and provides the core platform every other piece of software depends on. Question 27. An IT manager is categorizing the programs running on company computers. She needs to distinguish between software that provides a platform for other programs versus software built for specific user tasks like word processing. What general term correctly describes the platform providing category? Your options are A. Firmware built into hardware, B. Application software for tasks, C. Graphical user interface layer, D. System software including OS. Before I reveal it, which one do you think is right? The correct answer is D. System software including OS. D is correct because system software provides a platform for other software and includes examples like operating systems and utility programs. It supports application software that users run for specific tasks like word processing or browsing. A is wrong because firmware is specialized low-level software embedded directly into hardware devices like printers or routers. It is not the general category of platform-providing software that supports the applications users run on their computers daily. B is wrong because application software includes programs built for specific user tasks, which is the category being distinguished from. The manager needs the opposite category that provides the platform, not the one containing word processors. C is wrong because a graphical user interface layer is one feature provided by operating systems, not the general category itself. GUI is a component within system software rather than a broad classification of platform providing software. Software falls into 2 broad categories based on the role it plays. Understanding the difference comes down to one key question: does the program serve the machine, or does it serve a specific user goal? System software is the infrastructure layer. It includes the operating system and utility programs, and its job is to manage hardware, schedule work, and expose services so that other programs can exist at all. Application software sits on top, calling on system software for memory, storage, and device access rather than touching hardware directly. A word processor, for example, asks the operating system to open a file. The operating system does the low-level work and hands back the result. The markers for system software are words like platform, supports other programs, operating system, and utilities. Firmware is narrower. It is embedded device code, not the full platform category. A graphical interface is a feature, not a category. Whenever a question asks for the platform providing category of software, the answer is system software, with the operating system as its centerpiece. Application software is the payoff layer, built for the specific task people actually want to accomplish. Question 28. A systems administrator notices that the company server loads several programs into memory simultaneously and keeps them all ready so the CPU can switch between them rapidly to maximize resource use. Which operating system technique is the server actively using here? Your options are A. Single contiguous memory use, B. Multi-programming technique, C. Batch processing without intervention, D. Dumb terminal relying on server. What's your answer? Commit to one before I continue. The correct answer is B. Multi-programming technique. B is correct because multi-programming loads multiple programs into memory and executes them concurrently by switching CPU attention between them. This approach maximizes resource use and keeps the CPU busy rather than idle while awaiting input or output. A is wrong because single contiguous memory use loads only one entire program into memory at a time. This severely limits resource use and directly contradicts the scenario where multiple programs are loaded simultaneously for concurrent execution. C is wrong because batch processing runs a group of tasks automatically without manual intervention between them. While efficient, it describes how jobs are queued and processed rather than how multiple programs share memory and CPU time concurrently. D is wrong because a dumb terminal has no processing power and relies on a central computer for all computing tasks. It is a hardware concept describing user input devices, not a memory management technique used by the server. Multi-programming is an operating system technique that keeps several programs loaded in memory simultaneously, allowing the processor to stay busy rather than sitting idle while waiting for slow operations to complete. The operating system loads multiple programs into memory together and tracks each one's state. The processor runs one program until it must wait for a slow operation, like a disk read, then immediately switches to another program that is ready to run. The cycle is straightforward. When a running program stalls waiting for input or output, the operating system switches the processor to another ready program, and the original program rejoins the pool once its slow operation finishes. Multi-programming is often confused with three other concepts. Single contiguous memory holds only one program at a time, the direct opposite. Batch processing describes how jobs are queued automatically, not how memory is managed. A dumb terminal is simply a hardware device with no processing power of its own. Whenever you see the phrase multiple programs in memory with the processor switching among them to stay busy, that is the fingerprint of multi-programming, the technique designed to maximize processor utilization. Question 29. An engineer is designing control software for a medical infusion pump that must respond to sensor inputs within milliseconds, since delayed responses could harm patients. Timing is absolutely critical and no delays are permissible. Which type of operating system best fits this use case? Your options are A. Batch processing operating system, B. Time-sharing operating system, C. Real-time operating system, D. Multi-programming operating system. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is C. Real-time operating system. C is correct because a real-time operating system must respond to inputs predictably and quickly, with no delays allowed. This makes it essential for medical machines, robots, missiles, and nuclear reactors where timing is critical for safety. A is wrong because batch processing operating systems run grouped tasks automatically without manual intervention. This model suits long-running jobs that do not need immediate responses and clearly fails the millisecond timing requirement of a medical infusion pump. B is wrong because time-sharing operating systems let multiple users share CPU time slices concurrently. While responsive for interactive use, they do not guarantee the strict predictable timing required for critical medical devices responding to sensor inputs. D is wrong because multi-programming operating systems load multiple programs into memory to maximize resource use. They improve throughput, but do not guarantee the deterministic response times required for safety-critical medical equipment like an infusion pump. A real-time operating system is built around one core promise: guaranteed, predictable response to every input within a strict time limit. Speed matters, but predictability matters more. A late response is treated as a failure, even if the average is fast. 3 principles define a real-time OS. Every operation is tightly bounded. The scheduler prioritizes deadlines over throughput, and the design eliminates unpredictable pauses, so determinism is guaranteed regardless of system load. When a sensor event arrives, the real-time scheduler immediately dispatches the critical task, ensuring it completes inside the guaranteed window, every single time, not just on average. Batch systems run long jobs with no urgency. Time sharing keeps interactive users responsive, but makes no hard guarantees. Multi-programming raises throughput without bounding response time. Only a real-time OS guarantees worst-case deadlines. Whenever a scenario involves millisecond deadlines, safety-critical consequences of delay, and the need for predictable response every time, that is the signature of a real-time operating system. Medical devices, avionics, robots, and reactor controls all depend on exactly this guarantee. Question 30. A large payroll department schedules all end-of-month pay calculations to run overnight on the company mainframe, executing hundreds of jobs automatically in sequence without any human intervention occurring between jobs. Which operating system processing approach does this workflow most clearly illustrate? Your options are A. Batch processing approach, B. Interactive real-time processing, C. Preemptive scheduling approach, D. Single-user dedicated system. Which would you go with? Lock it in before the reveal. The correct answer is A. Batch processing approach. A is correct because batch processing runs groups of tasks on a computer automatically without requiring people to control each step. Jobs are queued up and processed in sequence, which perfectly describes the overnight payroll run scenario here. B is wrong because interactive real-time processing requires immediate responses to user inputs or sensor events. The overnight payroll run has no interactive user component and no critical response time requirement, so this classification does not fit the scenario. C is wrong because preemptive scheduling describes how the CPU interrupts and switches between running processes. It is a CPU scheduling concept rather than a broader description of how payroll jobs are grouped and processed overnight automatically. D is wrong because a single user dedicated system implies only one person using the machine for one task at a time. The scenario describes hundreds of jobs running sequentially, which is batch processing rather than single user dedicated usage. Batch processing is an operating system approach where jobs are collected into a queue and run automatically in sequence, with no human stepping in between them. Understanding what makes batch processing distinct helps clarify how operating systems manage large volumes of routine work. Jobs are submitted into a queue along with all the instructions each one needs. The operating system takes the first job, runs it to completion, then moves to the next, continuing until the queue is empty, with no interactive prompt and no waiting on a user. 3 defining traits set batch processing apart. Jobs are queued up in advance. The system runs them completely unattended, and execution is strictly sequential and automatic from start to finish. Batch processing is often confused with interactive, real-time, or single-user approaches. Interactive and real-time systems demand immediate responses to users or sensors, the opposite of unattended batching. A single-user dedicated system serves just one person on one task, a completely different model. Whenever you see words like queued jobs, no intervention, automatic, and in sequence, often running overnight when hardware is otherwise idle, that description is pointing directly at batch processing. Question 31. A software developer is running a program that needs more memory than the computer physically has installed. The operating system uses disk storage to create the illusion of a large continuous memory space, letting the program execute anyway. Which memory management technique is this? Your options are A. Single contiguous memory management, B. Fixed partition technique, C. Page memory management only, D. Virtual memory management. Don't overthink it. Which one feels right? The correct answer is D. Virtual memory management. D is correct because virtual memory is a memory management technique that creates the illusion of large continuous memory space by using disk storage to extend physical memory. This allows programs larger than available RAM to still run. A is wrong because single contiguous memory management loads one entire program into one big memory block. It does not extend memory using disk storage and would simply fail if a program exceeded the physically installed memory. B is wrong because fixed partition technique divides memory into fixed size partitions, each holding one process. This approach does not use disk storage to simulate additional memory space when programs exceed what is physically available on the machine. C is wrong because paged memory management divides memory into frames and programs into pages, but by itself does not create the illusion of extra memory via disk. Virtual memory builds on paging to add disk-based extension. Virtual memory is a technique that gives programs the illusion of having more memory than the machine physically contains. The operating system achieves this by using disk space to extend physical memory, so even an oversized program can run. Virtual memory exists for three key reasons. Programs and their data often exceed available physical memory. Running many programs simultaneously would exhaust memory fast, and purchasing enough RAM for every workload is simply wasteful. The system divides a program's address space into pages, keeping only active pages in physical memory and storing the rest on disk. When the program touches a page that is on disk, the OS fetches it, possibly evicting another page to make room. Address translation maps the program's continuous view onto real physical locations seamlessly. Virtual memory is often confused with related techniques. Single contiguous memory simply fails if the program does not fit. Fixed partitioning divides memory into preset sections without disk extension. Plain paging provides pages and frames, but does not manufacture extra memory on its own. Virtual memory is the technique that uses disk to simulate more memory than physically exists. Whenever you see phrases like illusion of memory, extend physical memory with disk, or larger than RAM, those are the markers of virtual memory. I'd say the technique that makes a machine appear far more capable than its hardware alone. Question 32. A systems analyst notices that a server is spending most of its time moving pages between RAM and disk rather than doing useful computation. System performance has degraded dramatically as excessive paging operations dominate the CPU. Which condition is the server clearly experiencing? Your options are A. Proper virtual memory operation, B. Successful demand paging, C. Thrashing condition, D. Normal context switching activity. Got a guess? Lock it in. The correct answer is C. Thrashing condition. C is correct because thrashing is a condition where excessive page operations such as page swapping occur, leading to severely reduced system performance. The CPU spends more time moving pages than executing actual useful program instructions efficiently. A is wrong because proper virtual memory operation balances page swapping with productive computation, so programs run smoothly. The scenario describes severely degraded performance caused by excessive paging, which is specifically the breakdown condition called thrashing instead. B is wrong because successful demand paging brings pages into memory when needed, without overwhelming the system. The scenario shows pages being moved so frequently that useful work stops, which is the failure mode rather than successful paging. D is wrong because normal context switching activity involves saving and restoring CPU state between processes, not moving memory pages. While both involve overhead, the scenario specifically describes excessive page movement, which defines thrashing rather than context switching. Thrashing is a failure condition where a system spends most of its time moving pages between physical memory and disk instead of doing useful work. It's not normal paging. It's a breakdown where paging itself becomes the problem. Every program relies on a working set, the pages it actively needs to run. When the combined working sets of all running processes exceed available physical memory, the system can never satisfy all demands at once, and it falls into a self-defeating loop. A page fault forces the OS to load a page from disk, evicting another page to make room. If that evicted page is needed moments later, another fault fires, triggering another swap. As this repeats, the processor becomes overwhelmed with disk transfers and useful execution slows to almost nothing. Thrashing is often confused with three normal operations: successful demand paging, healthy virtual memory management, and context switching. The key difference is that demand paging and virtual memory keep paging under control while real work proceeds, and context switching involves saving processor state, not moving pages at all. When a system's disk is grinding constantly, performance has cratered, and the processor is stuck shuttling pages rather than computing. That pathological state is thrashing, paging overhead that has completely swamped useful work. Question 33. An operating system designer is implementing a policy where pages of a program are loaded from secondary memory into RAM only at the moment they are actually needed by the running process. Which memory management strategy does this policy illustrate? Your options are A. Demand paging strategy, B. Fixed partition loading strategy, C. Single contiguous strategy, D. Compaction strategy after use. Which one is it? Pause the video if you need more time. The correct answer is A. Demand paging strategy. A is correct because demand paging loads pages into memory only when they are needed during execution. If a needed page is not currently in memory, it is loaded from secondary memory, which conserves physical memory resources efficiently. B is wrong because fixed partition loading divides memory into predetermined size partitions that each hold one process from start. It does not load portions of programs selectively as they are needed during execution like demand paging does. C is wrong because single contiguous strategy loads an entire program into one big memory block upfront before execution begins. This is the opposite of loading pages on demand, since the full program must fit before running. D is wrong because compaction rearranges programs already in memory to combine empty spaces into one large free partition. It addresses fragmentation after allocation rather than controlling when pages are initially loaded into memory during execution. Demand paging is a memory management strategy built around one simple rule: only load a page when the running process actually needs it. Pages that are never touched stay on disk for the entire session. Think of a large program like a thick book. Rather than reading every page before you begin, you open only the chapter you need right now. The rest stays on the shelf until or unless you call for it. When the processor references a page not yet in memory, a page fault fires. The operating system fetches that page from disk, places it in a free frame, updates its page table, and resumes execution, all transparent to the program. It helps to contrast demand paging with the alternatives. Fixed partition and single contiguous loading both place an entire program into memory before execution begins. The opposite of lazy loading. Compaction reorganizes already loaded pages to reduce fragmentation, and has nothing to do with when pages are loaded. Whenever a description says pages are loaded only when needed, or that a page fault brings them in, that is demand paging. It is the just-in-time loading policy that makes virtual memory practical. Question 34. A memory manager divides the computer's main memory into several fixed-size sections, each one capable of holding exactly one process. This allows multiple programs to reside in memory at the same time, but limits partition sizes. Which technique does this describe? Your options are A. Dynamic partition with variable sizes, B. Single contiguous memory management, C. Page memory with frames, D. Fixed partition technique. Take a second. Which answer would you pick? The correct answer is D. Fixed partition technique. D is correct because fixed partition technique divides memory into fixed size partitions where each one holds a single process. This allows multiple programs to run at once but wastes space when processors do not perfectly fit partitions. A is wrong because dynamic partition uses variable size partition size based on process needs at load time. The scenario explicitly describes fixed predetermined partition sizes, which is the opposite of the flexible sizing dynamic partitioning provides to processes. B is wrong because single contiguous memory management loads only one program into one large memory chunk, not several programs. The scenario allows multiple programs to reside concurrently, which contradicts the single program limitation of contiguous memory management directly. C is wrong because page memory uses small same-size blocks called frames that can hold scattered pages of programs. The scenario describes fixed sections holding entire processes, not the scattered page and frame model of page memory management here. Fixed partitioning is one of the earliest techniques for allowing multiple programs to reside in memory at the same time. Memory is divided into a set of predetermined sections when the system is configured, and those boundaries never change. Each partition holds exactly one process. When a process is smaller than its partition, the leftover space sits idle. This wasted space inside a partition is called internal fragmentation, and it is the defining weakness of the approach. It helps to contrast fixed partitioning with related schemes. Dynamic partitioning tailors partition sizes to each process, removing the rigidity. Single contiguous memory holds just one program at a time. Paging scatters program pages across small uniform frames rather than placing whole processes in large fixed sections. Fixed partitioning made multi-programming possible on simple hardware with minimal bookkeeping. The price of that simplicity is rigidity. Preset section sizes cause internal fragmentation and prevent processes larger than any partition from loading at all. Question 35. A computer science textbook explains that memory is broken into small same-sized blocks, while programs are split into equal pieces that can be loaded into any available block, even scattered throughout memory. An operating system table tracks where each piece lives. What technique is this? Your options are A. Fixed partition memory technique, B. Single contiguous memory model, C. Page memory management technique, D. Dynamic partition with compaction. Before I reveal it, which one do you think is right? The correct answer is C. Page memory management technique. C is correct because page memory management breaks memory into small blocks called frames and splits programs into same-size pages loaded into available frames. The page map table tracks the locations, allowing scattered, non-contiguous placement of program pieces. A is wrong because fixed partition memory technique holds one entire process per partition rather than splitting programs into pages. The scenario describes scattered pieces spread across available blocks, which is specifically paging rather than simple fixed partitioning. B is wrong because single contiguous memory model requires the entire program to occupy one continuous memory block. The scenario explicitly allows pieces of the program to be scattered across memory, directly contradicting single contiguous requirements for loading. D is wrong because dynamic partition with compaction uses variable partition sizes and rearranges them to reduce fragmentation. It does not split programs into fixed-size pages placed into same-sized frames, which is the distinctive feature of paging. Paged memory management is a technique that eliminates the need for a program to occupy one continuous block of physical memory. Understanding how it works requires looking at how memory and programs are each divided. Physical memory is divided into fixed-size blocks called frames, and each program is divided into equal-size pieces called pages. Because pages and frames are the same size, any page can be placed into any free frame. The program's pieces may end up scattered anywhere in memory. The operating system maintains a page map table that records which frame holds each page. When a program references a memory address, the system uses the table to translate the page number and offset into the correct physical frame. The scattering is completely invisible to the running program. Paging is often confused with other memory schemes. Fixed partitioning holds one whole process per preset partition. Single contiguous memory requires the entire program in one unbroken block. Dynamic partitioning with compaction reshuffles variable size partitions. Only paging uses uniform pages placed into uniform frames tracked by a table. Whenever you see equal size pages loaded into equal size frames, scattered across memory, with an OS table tracking every location, that is paged memory management, solving fragmentation by removing the need for any continuous block. Question 36. An operating system student is studying the life cycle of processes inside the OS. She learns that a process can be in several stages during its lifetime, from being newly created until it is completely finished. Which sequence lists valid process states? Your options are A. New, ready, running, waiting, terminated. B. Initial, pending, executing, done, closed. C. Start, queue, active, hold, complete. D. Create, wait, go, stop, gone. What's your answer? Commit to one before I continue. The correct answer is A. New, ready, running, waiting, terminated. A is correct because process states include new for creation, ready for waiting on CPU, running for active execution, waiting for a non-CPU resource, and terminated when execution ends. These are the standard OS process lifecycle stages. B is wrong because while the terms sound plausible, they are not the standard process state names used in operating system theory. Operating systems textbooks and exams specifically use new, ready, running, waiting, and terminated as the official states. C is wrong because start, queue, active, hold, and complete are informal descriptive terms rather than the standard process state names. The OS curriculum and official textbooks require the precise terminology of new, ready, running, waiting, and terminated. D is wrong because create, wait, go, stop, and gone are overly casual approximations of process states. Operating systems use the precise industry standard terminology of new, ready, running, waiting, and terminated for process lifecycle classification and tracking. Every process passes through a defined set of states as the operating system manages it from creation to completion. Understanding these states reveals how the OS schedules and controls concurrent work. A process starts anew as the OS builds its structures, then moves to ready where it queues for the processor. The scheduler dispatches it to running, and if it needs a resource like a disk read, it shifts to waiting before returning to ready. Finally, when work is complete, it reaches terminated and the OS reclaims its resources. The 5 standard states are new, ready, running, waiting, and terminated. These are the precise terms used in operating system theory and textbooks, not informal alternatives like initial, pending, active, hold, or gone. Exams and schedulers both rely on the exact standard names, recognizing new, ready, running, waiting, and terminated, rather than plausible sounding substitutes, is the key skill here. Question 37. A CPU running multiple processes must pause one process and resume another so they can share the single CPU. The operating system saves the state of the current process and restores the state of the next process. What is the specific action called? Your options are A. Thrashing between memory pages, B. Demand paging on request, C. Compaction of memory spaces, D. Context switch between processes. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is D. Context switch between processes. D is correct because a context switch is the process of storing and restoring the state of a CPU so multiple processes can share a single CPU. This enables multitasking even on systems with only one processor. A is wrong because thrashing describes excessive paging operations that degrade system performance, not the orderly process of saving and restoring CPU state. It is a failure mode in memory management rather than a planned process management operation. B is wrong because demand paging brings pages from disk into memory only when they are needed. It is a memory management technique for pages rather than the CPU state save and restore action described between executing processes here. Cell is wrong because compaction rearranges programs in memory to combine empty spaces into one larger free region. It is a memory management technique for addressing fragmentation, not a CPU state management action for sharing the CPU between processes. A context switch is how an operating system shares a single processor among many processes. Understanding it means knowing exactly what gets saved, what gets restored, and why that matters for multitasking. When the OS decides to switch, it copies the running processor's program counter and register values into that processor's control block. It then loads the next processor's saved context from its control block back into the processor, so that process resumes exactly where it left off. The saved state includes 3 essentials: the program counter, which tracks where execution stopped, the register values, holding the processor's working data, and all of this is stored in the process control block so the OS can retrieve it later. A context switch is a process management action, not a memory operation. Thrashing, demand paging, and compaction all involve memory management. The telltale markers of a context switch are saved registers and a saved program counter being swapped between processors to share the processor. Whenever you see saving one processor's processor state and restoring another so they can take turns on a single CPU, that is a context switch, the engine behind multitasking. Question 38. A time-sharing operating system assigns each process a fixed time slice, after which the CPU is preempted and the next process in the queue gets its own equal time slice. Processes rotate in a fair circular order. Which scheduling algorithm is this? Your options are A. First come first served scheduling, B. Round robin scheduling algorithm, C. Shortest job next non-preemptive, D. Non-preemptive priority scheduling. Which would you go with? Lock it in before the reveal. The correct answer is B. Round-robin scheduling algorithm. B is correct because round-robin is a CPU scheduling algorithm where each process receives a fixed time slice in a rotating order. It is preemptive and well-suited for time-sharing systems, ensuring fair CPU access for all processes. A is wrong because first-come, first-served processes request strictly in the order they arrive, without preemption. It does not rotate processes through fixed time slices, but lets each job run to completion before the next one begins executing. C is wrong because shortest job next selects the process with the shortest expected execution time and is non-preemptive. It does not give every process equal rotating time slices, but rather picks whichever job is expected to finish most quickly. D is wrong because non-preemptive priority scheduling selects processes based on priority levels and lets each run to completion. It does not rotate processes through equal time slices in the preemptive fair sharing way round-robin specifically does here. Round-robin is a CPU scheduling algorithm built around one core idea. Every process gets an equal fixed slice of processor time, called a time quantum, in a rotating order. Ready processes wait in a queue. The scheduler gives the front process its time quantum on the CPU. When the slice expires, that process is preempted and moved to the back of the queue, and the next process gets its turn. The rotation continues until all work is done. 3 properties make round-robin effective. A fixed time slice caps how long any one process runs. Fair rotation guarantees every process gets regular turns, and preemption ensures the CPU is forcibly reclaimed when a slice expires, so no process can monopolize the processor. It helps to contrast round-robin with its neighbors. First come, first served runs each job to completion with no slicing. Shortest job next favors the quickest process. Priority scheduling orders by importance. Only round-robin combines fixed equal time slices with preemption and fair circular rotation, making it the natural fit for time-sharing systems. Question 39. A system administrator configures the CPU scheduler to interrupt a currently running process so that a higher priority process can take control, even before the first process finishes its current task. Which type of scheduling is he enabling with this configuration? Your options are A. First come first served fairness, B. Non-preemptive scheduling strictly, C. Preemptive CPU scheduling, D. Single contiguous batch ordering. Don't overthink it. Which one feels right? The correct answer is C. Preemptive CPU scheduling. C is correct because preemptive CPU scheduling allows the operating system to interrupt a running process and switch to another process before the current one completes. This enables responsive handling of high priority tasks when they arrive unexpectedly. A is wrong because first come first served processes request an arrival order without interrupting any running process. This conflicts directly with the scenario where the scheduler must interrupt a running job to handle a newly arrived higher priority task. B is wrong because non-preemptive scheduling explicitly forbids interrupting a running process until it finishes or blocks voluntarily. The scenario describes exactly the opposite, where the OS does interrupt running tasks, making this classification clearly incorrect here. D is wrong because single contiguous batch ordering is not a CPU scheduling category at all, but a memory and job management concept. It has no bearing on whether or not running processes can be interrupted during execution. Preemptive scheduling is the operating system's ability to forcibly take the processor away from a running process before it finishes. No permission required. Preemption exists for three reasons: to keep the system responsive, to honor priorities by letting urgent tasks jump in immediately, and to prevent any single process from monopolizing the processor, which is critical for interactive and real-time systems. When a high-priority process becomes ready or a time slice expires, the scheduler interrupts the running process, performs a context switch to save its state, and hands the processor to the chosen process. The interrupted process waits in the ready queue to resume later. The key contrast: preemptive scheduling lets the OS force a switch and interrupt a process mid-task, while non-preemptive scheduling, like first come first served, requires each process to run to completion or block on its own before the next one starts. Whenever you see words like interrupt, force a switch, or higher priority takes over before it finishes, that's the fingerprint of preemptive scheduling, or the OS acting on its own initiative. Question 4. An operating system must keep complete information about every running process on the computer, including its program counter, CPU register values, memory details, and current state. Which specific data structure does the OS use to store all this process information together? Your options are: A. Process control block, B. Page map table only, C. File allocation table, D. Virtual memory directory. Got a guess? Lock it in. The correct answer is A. Process control block. A is correct because the process control block is a data structure the operating system uses to store all information about a process. It contains the program counter, CPU register values, state and memory information for each process. B is wrong because the page map table tracks the mapping between virtual pages and physical frames in memory management. It holds memory-related information but does not store the full process context like register values and program counter. C is wrong because a file allocation table tracks where files are stored on secondary memory like a hard drive. It is a file system structure and has no role in storing information about currently running processes here. D is wrong because a virtual memory directory would relate to virtual address translation rather than process management. It does not hold the comprehensive set of process state, register values, and program counter that the PCB specifically holds. The process control block is the data structure an operating system uses to store everything it needs to know about a single process. It is the dedicated record that follows a process from creation to termination. Inside each process control block, the operating system records the program counter, register values, current process state, and memory information. Everything needed to pause and resume that process exactly where it left off. During a context switch, the operating system saves the running process's program counter and registers into its control block, then reads the next process's values out of its own control block. This is how the OS switches between many processes without losing any state. The process control block is often confused with other OS structures. A page map table only maps virtual pages to physical frames. A file allocation table tracks where files sit on disk. A virtual memory directory concerns address translation. None of them stores the complete process context, only the PCB does. Whenever you see a question about a structure that stores program counter, registers, state, and memory details together, that is the process control block, the cornerstone of scheduling and context switching. Question 41. A hardware architecture textbook describes a classic computer model where the input-output devices, CPU with its arithmetic logic unit and control unit, and memory unit all connect together. Data and instructions share the same memory and travel via buses. Which architecture is this? Your options are A. Harvard architecture with separate memory, B. Client-server distributed architecture, C. Peer-to-peer networked architecture, D. Von Neumann architecture. Which one is it? Pause the video if you need more time. The correct answer is D. Von Neumann architecture. D is correct because von Neumann architecture describes a computer with input-output devices, a CPU containing the ALU and control unit, and a memory unit. Data and instructions are stored in the same memory and accessed via buses. A is wrong because Harvard architecture uses physically separate memories for instructions and data. The scenario specifically describes data and instructions sharing the same memory, which is the defining characteristic of von Neumann rather than Harvard architecture. B is wrong because client-server distributed architecture is a networking model where clients request services from centralized servers. It is not a hardware architecture describing the internal structure of a single computer with CPU, memory, and buses. C is wrong because peer-to-peer networked architecture describes a network model where devices act as both clients and servers. It is a networking concept rather than a hardware architecture describing the internal components of a single computer system. Von Neumann architecture is the foundational design model that describes how nearly every general-purpose computer is organized internally. Understanding its structure helps explain why a single machine can run any program. The architecture has 5 parts: input devices, output devices, a CPU containing a control unit and arithmetic logic unit, and a single memory unit. All components are connected by shared pathways called buses. And crucially, both data and program instructions live together in that one memory. The defining insight is the stored program concept. Instructions are not physically wired into the machine but stored in memory just like data. This means the same hardware can run a word processor one moment and a game the next, simply by loading different instructions. Von Neumann is often contrasted with Harvard architecture, which uses physically separate memories for instructions and data. Client-server and peer-to-peer describe relationships among networked machines, not the internal layout of a single computer, so they are in a completely different category. Whenever you see a description of input and output devices, a CPU with a control unit and ALU, and a single shared memory for both data and instructions connected by buses, that is von Neumann architecture, the stored program design underlying modern computing. Question 42. A computer science student studies the components inside the CPU. She learns about the part that coordinates activities of all computer components and manages the fetch-execute cycle, acting as the organizing force of the processor. Which CPU component does this describe? Your options are A. Arithmetic logic unit ALU, B. Control unit of CPU, C. Cache memory for speed, D. Register holding temporary values. Take a second. Which answer would you pick? The correct answer is B. Control unit of CPU. B is correct because the control unit is the organizing force in the computer and is in charge of the fetch-execute cycle. It coordinates the activities of all other computer components, directing how instructions are fetched and executed. A is wrong because the arithmetic logic unit performs arithmetic calculations and logical operations inside the CPU. It is the computational workhorse of the processor rather than the coordinating organizer that manages the fetch-execute cycle across components. C is wrong because cache memory is a small, fast storage area that holds frequently used data and instructions. It speeds up CPU access, but does not coordinate the fetch-execute cycle or direct the activities of other components. D is wrong because A register is a tiny superfast storage location inside the CPU that holds temporary values. Registers store working data and instructions but do not coordinate the overall activities of computer components during execution. The control unit is the part of the CPU that directs and coordinates every other component. It doesn't perform calculations itself. Its job is organization, direction, and timing. Inside the processor, the arithmetic logic unit handles math and logic. Registers hold temporary values, and memory stores instructions, but the control unit orchestrates all of them, issuing the signals that make each part act at exactly the right moment. The control unit drives the fetch-execute cycle. It fetches the next instruction from memory using the program counter, decodes it to determine what operation is needed, and then issues control signals to execute it. The cycle repeats continuously to run a program. It's easy to mix up the control unit with other processor components. The arithmetic logic unit computes, cache speeds up memory access, and registers hold working values. Only the control unit coordinates all the others and manages the fetch-execute cycle. Whenever you see words like coordinates, directs, organizes, or fetch-execute cycle, they're pointing at the control unit, the processor's conductor, turning stored instructions into coordinated action. Question 43. A computer architecture professor describes two special registers inside the control unit. One holds the instruction currently being executed by the CPU, while the other holds the memory address of the next instruction. Which pair correctly identifies these two registers? Your options are A. ALU register and cache register, B. Base register and bounds register, C. Instruction register and program counter, D. Page table register and stack register. Before I reveal it, which one do you think is right? The correct answer is C. Instruction register and program counters. C is correct because the instruction register holds the instruction currently being executed as a holding spot for the CPU's current work. The program counter contains the address of the next instruction to be executed by the CPU. A is wrong because ALU register and cache register are not the standard names for the two special control unit registers. The correct pairing uses the specific terms instruction register and program counter, which are universally recognized industry terminology. B is wrong because base register and bounds register are used for memory address translation and range checking within a memory segment. They are not the two special registers inside the control unit for tracking current and next instructions. D is wrong because page table register and stack register serve different purposes in memory management and subroutine calls respectively. Neither holds the current instruction nor the address of the next instruction the way the IR and PC do. Inside every processor's control unit, two special registers work together to keep instructions running in the correct order. Understanding their distinct roles is the key to this concept. The instruction register holds whatever instruction the processor is working on right now. It is the holding spot the control unit reads to decode and execute. The program counter looks ahead, storing the memory address of the instruction that will run next, so the processor never loses its place. At the start of each fetch-execute cycle, the processor reads the address stored in the program counter to fetch the next instruction from memory into the instruction register. The program counter then advances to the following address, and the control unit decodes and executes whatever is now sitting in the instruction register. When that finishes, the cycle repeats. Distractor pairs like base and bounds registers or page table and stack registers name real components, but they handle memory range checking, memory mapping, and subroutine calls. None of them hold the current instruction or point to the next one. Only the instruction register and program counter fill those two specific roles. Whenever a question describes one register holding the instruction being executed and another holding the address of what comes next, that is always the instruction register and the program counter. Question 44. A performance engineer explains that modern CPUs include a small, very high-speed memory built directly into the processor chip. This memory stores frequently used data and instructions so the CPU avoids fetching them from the slower main RAM. Which component is this? Your options are A. CPU cache memory, B. ROM firmware storage, C. virtual memory disk extension, D. secondary tape storage. What's your answer? Commit to one before I continue. The correct answer is A. CPU cache memory. A is correct because CPU cache is small, special high-speed memory usually built into the processor chip. It stores frequently used data and instructions so the CPU can access them quickly without fetching from slower main RAM. B is wrong because ROM firmware storage holds permanent instructions like startup code. It is not a speed optimization layer inside the CPU, but rather a non-volatile memory outside the processor containing boot instructions and other fixed firmware. C is wrong because virtual memory uses disk storage to extend physical memory, which is actually much slower than RAM. This is the opposite of the speed-focused processor-built cache described in the scenario for accelerating data access. D is wrong because secondary tape storage is used for backup and archiving large data amounts where speed is not critical. This is one of the slowest storage media available and is the opposite of high-speed CPU cache memory. Cache is a small, extremely fast memory built directly into or right next to the processor. Its entire purpose is to hold the data and instructions the processor uses most often, so it can keep running without waiting on slower main memory. The processor sits at one end and main memory at the other. Cache bridges the gap, sitting right beside the processor and feeding it data almost instantly, so the processor rarely has to reach all the way to slow main memory. Every memory request follows the same path. The processor checks the cache first. A cache hit delivers data almost instantly. A cache miss forces a trip to main memory, but a copy is then stored in cache, so the next request will be a hit. Cache works because programs tend to reuse the same data and instructions over and over. This means a small cache catches the vast majority of requests, keeping the processor continuously fed and productive rather than idle. Cache is easily confused with other storage types. Firmware holds permanent startup instructions outside the processor. Virtual memory uses disk to extend capacity and is actually slower than main memory. Tape is slow archival storage. Only cache is the small, fast processor resident memory built to accelerate access to frequently used data. Question 45. A hardware reviewer is comparing two computer systems. One uses a narrower bus while the other uses a much wider bus. The reviewer explains that bus width determines the number of bits that can be transmitted simultaneously. What is the likely effect of a wider bus? Your options are A. Slower data transfer between parts, B. Reduced memory capacity overall, C. More cache misses at runtime, D. More data bits moving simultaneously. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is D. More data bits moving simultaneously. D is correct because bus width determines the number of bits that can be transferred at the same time. A wider bus can move more address or data bits simultaneously, which generally improves overall data transfer performance between components. A is wrong because slower data transfer contradicts what wider buses actually provide. Since more bits move at once across a wider bus, data transfer between parts should become faster rather than slower, ruling this option out entirely. B is wrong because reduced memory capacity is not a direct consequence of bus width changes. Bus width affects how many bits transfer simultaneously, not how much memory can be installed or addressed within the computer system overall. C is wrong because more cache misses would describe a memory access pattern issue, not a bus width effect. Bus width affects transfer speed between components rather than whether the CPU finds requested data in the cache or not. A bus is a set of shared electrical pathways that carry data, addresses, and control signals between computer components. The width of a bus determines how many bits it can carry at the same time, and that has a direct effect on performance. Bus width is simply the count of parallel lines in the bus. Each line carries 1 bit during a transfer, so a bus with more lines moves more bits in a single step. Double the width and you double the bits crossing at once. Think of each line as a lane on a highway. A narrow bus is a 2-lane road. Traffic moves but slowly. A wider bus adds more lanes, so more data flows through in the same amount of time, reducing the bottleneck between the processor and memory. It's important to separate bus width from other system properties. Cache misses depend on access patterns, not bus width. Memory capacity depends on addressing an installed RAM. Bus width governs only one thing: how many bits are transmitted at the same time. When you see the words bus width, parallel lines, or bits transmitted simultaneously, the signal is always the same. A wider bus moves more data per transfer, which generally improves transfer performance between components. Question 4x. A network engineer is choosing between 2 transport protocols for a video streaming service. Protocol X guarantees reliable, ordered delivery of all packets. Protocol Y sends data without establishing a connection and is faster but less reliable. Which statement correctly identifies both protocols? Your options are A. X is UDP, Y is TCP. B. Both X and Y are TCP. C. X is TCP, Y is UDP. D. Both X and Y are UDP. Which would you go with? Lock it in before the reveal. The correct answer is C. X is TCP, Y is UDP. C is correct because TCP breaks messages into packets, delivers them reliably, and reassembles them in order at the destination. UDP sends data without establishing a connection, providing faster but less reliable transmission suitable for streaming media. A is wrong because reversing the protocols gets both definitions wrong. TCP is the reliable ordered delivery protocol, while UDP is the connectionless faster but less reliable one. So Protocol X matches TCP rather than UDP here. B is wrong because classifying both as TCP ignores that Protocol Y is explicitly faster but less reliable with no connection establishment. These are the hallmarks of UDP, not TCP, so the 2 protocols cannot both be TCP. D is wrong because classifying both as UDP ignores that Protocol X guarantees reliable ordered delivery. This guarantee is the defining feature of TCP, not UDP, since UDP deliberately skips connection setup and delivery verification for speed. The Internet's transport layer relies on 2 protocols that make opposite trade-offs, TCP and UDP. Understanding what each sacrifices helps you pick the right one for any application. TCP guarantees that every packet arrives in order, resending anything lost, but this reliability costs extra overhead and delay. UDP skips the handshake and acknowledgements entirely, gaining speed while accepting that some packets may never arrive. TCP opens with a 3-way handshake, Sun, Sunak, Asake, before a single byte of data moves, then numbers every packet and waits for acknowledgement. UDP simply fires independent datagrams at the receiver with no setup and no confirmation. Applications that cannot tolerate missing data file transfers, and web pages need TCP's guarantees. Live video and voice streaming, where a dropped frame matters far less than keeping the stream current, are the classic UDP cases. Whenever a scenario stresses guaranteed ordered connection-based delivery, that is TCP. Whenever it stresses low delay and tolerates occasional loss, that is UDP. Keep those two profiles clear and the distinction becomes automatic. Question 47. A small business is setting up an office network where every workstation, printer, and server connects directly to a single central switch. This central device facilitates all communication between all devices on the network. Which specific network topology does this configuration describe? Your options are A. Star topology with central switch, B. Ring topology with circular path, C. Bus topology with single cable, D. Mesh topology with full redundancy. Don't overthink it. Which one feels right? The correct answer is A. Star topology with central switch. A is correct because star topology is a network configuration where all devices connect to a central hub or switch that facilitates communication between them. This matches the small business network setup exactly as described in the scenario. B is wrong because ring topology connects each device to two other devices, forming a circular data path without any central hub. This differs significantly from the centralized star arrangement described in the office networking scenario here. C is wrong because bus topology connects all devices to a single central cable, along which data is transmitted linearly. This uses a shared transmission line rather than a central hub or switch as the connection point for devices. D is wrong because mesh topology connects every device to every other device for full redundancy across the network. This is far more complex than a single central switch and was not the topology described in the business scenario. In the star topology, every device on the network connects directly to a single central switch or hub. That central device is the meeting point for all communication. No two end devices talk to each other directly. Each device has its own dedicated cable running to the center. When a workstation sends data to the printer, that data travels to the switch first, which then forwards it to its destination. The star layout became dominant in offices and homes for three reasons: easy expansion, fault isolation, and intelligent traffic management. Adding a device means running just one cable to the switch, and a broken cable takes down only that one device. It helps to contrast the star against other topologies. A ring links each device to two neighbors with no hub. A bus shares one cable among all devices. A mesh connects every device to every other. Only the star routes everything through a single central switch. Whenever a question describes all devices wired to one central switch or hub that handles all communication, that is a star topology, the central switch is the defining feature. Question 48. A user types a friendly website name like www.example.com into her browser, but her computer needs the numerical IP address to actually connect. Some system translates the human readable name into the required numerical address automatically behind the scenes. What system performs this translation? Your options are A. HTTP for web page delivery, B. TCP for reliable order delivery, C. Firewall for security filtering, D. Domain name system or DNS. Got a guess? Lock it in. The correct answer is D. Domain name system or DNS. D is correct because the domain name system manages the translation of domain names to IP addresses, making it possible to access websites using human-readable names rather than memorizing numerical IP addresses for every website a user visits. A is wrong because HTTP is the protocol used for transmitting web pages between servers and browsers. It carries the actual content of web pages, but does not perform the translation of domain names into numerical IP addresses needed first. B is wrong because TCP provides reliable ordered delivery of packets across the internet. It governs how data travel once a destination is known, not how human-readable names get translated into numerical IP addresses initially needed for routing. C is wrong because a firewall monitors and controls network traffic based on security rules. Its purpose is filtering for security rather than translating friendly domain names into the numerical IP addresses required for connection establishment. The Domain Name System, or DNS, is the Internet service that bridges the gap between how humans think about the web and how machines actually connect to it. People remember names, but computers route by numbers. DNS acts as the directory that automatically maps a human-readable domain name to the numerical Internet protocol address a machine needs to make a connection. When you type a website name into your browser, your computer silently asks DNS for the matching numerical address. DNS looks it up and returns it in a fraction of a second, before the page request is even sent, so you never see the numbers. DNS is often confused with other Internet services. HTTP carries web page content but does not resolve names. TCP reliably delivers data once a destination is already known. A firewall filters traffic for security. Only DNS performs the single job of translating domain names into numerical addresses. Whenever a scenario describes turning a human-readable website name into the numerical address needed to connect, that is DNS, the step that happens first, automatically, so every other service can do its job. Question 49. A network architect is labeling 3 company networks by geographic scale. Network A covers a single office building. Network B covers the entire downtown city area, and Network C spans multiple states connecting regional offices. Which sequence of terms correctly labels these networks? Your options are A. WAN, LAN, MAN for A, B, C. B. MAN, WAN, LAN for A, B, C. C. LAN, MAN, WAN for A, B, C. D. 1 MAN, LAN for A, B, C. Which one is it? Pause the video if you need more time. The correct answer is C. LAN, a man, WAN for A, B, C. C is correct because a local area network covers a limited area like an office. A metropolitan area network spans a city, and a wide area network connects networks across very large geographic areas like multiple states or countries. A is wrong because labeling the office building as one reverses the size hierarchy completely. WAN describes the largest geographic scale spanning regions or states, while a single building should be classified as a LAN at the smallest scale. B is wrong because labeling the office building as MAN oversizes the single building network. MAN describes a city-scale network, while a single office building falls into the smaller LAN category for limited area networks typically under that scale. D is wrong because labeling the multi-state network as LAN drastically undersizes it, while labeling a single office as WAN oversizes it. The sequence gets both extremes backwards relative to the proper LAN-MAN WAN size hierarchy order. Networks are classified by how much geographic ground they cover. The 3 core categories form a size hierarchy, each one spanning a larger area than the last. A local area network or LAN covers a single building or office. A metropolitan area network or MAN spans a city. A wide area network or WAN reaches across states, countries, or even continents. Each tier has different infrastructure needs. A LAN uses cabling owned by one organization. A MAN ties together city locations. A WAN links distant offices using leased lines or shared public infrastructure. Visually, think of the 3 as nested zones of reach. LAN is the smallest footprint. MAN wraps around it at city scale. and WAN extends outward across the greatest distances. The only real trap is scrambling the order. Keep the hierarchy straight, building maps to LAN, city to MAN, and multi-state or global reach to WAN, and the question becomes straightforward. Question 50. An internet engineer explains that when data is sent over the internet, it gets broken into small units containing both the data and routing information. These units travel potentially different paths to reach their destination, where they are reassembled. What term describes this method? Your options are A. Circuit switching with dedicated line, B. Packet switching across the network, C. Broadcast to every connected device, D. Ring rotation and circular path. Take a second. Which answer would you pick? The correct answer is B. Packet switching across the network. B is correct because packet switching is a method of data transmission where data is broken into packets and sent over various routes to its destination, where it is reassembled. This enables efficient use of network resources simultaneously. A is wrong because circuit switching reserves a dedicated communication line between endpoints for the entire transmission. It does not break data into packets taking potentially different routes, but uses one reserved path throughout the complete exchange. C is wrong because broadcasting sends the same data to every connected device rather than routing packets to a specific destination. It is a transmission pattern rather than a method of splitting data into routable units as described. D is wrong because ring rotation describes how data circulates through a ring topology network, passing from device to device. It is a physical topology concept rather than a data transmission method that breaks data into routable packets. Packet switching is the fundamental method the internet uses to move data. Rather than sending a message as one continuous stream, it breaks data into small independent units and routes them across the network. Every piece of data is divided into packets. Each packet contains a fragment of the message, addressing information so the network knows where it came from and where it's going, and a sequence number so the destination can put everything back in order. The packets are released into the network independently. Each router along the way examines the destination address and chooses the best available path forwarded. Packets from the same message can take completely different routes and may even arrive out of order. Unlike circuit switching, which reserves one dedicated path for an entire conversation, packet switching shares network links across many users at once. If a link is congested or broken, packets simply take another route, making the network resilient to failures. Packet switching means splitting, independent routing, and reassembly. Those three ideas together, not a single reserved path, are what define how the internet actually works.
You have reached the end of our first question set. For the free complete exam preparation, visit our website link in the description, where you find thousands more practice questions and comprehensive study guides. Thanks for studying with us today. See you in the next video.